Hello everyone, I'm going to present our work, Weakly Supervised Multitasking Representation Learning for Human Activity Analysis. Human activity analysis is a core part in many user-centric applications, and it opens up a vast potential to improve our daily life. There has been extensive research on human activity recognition, using different sensors and different machine learning algorithms, but most previous works have some limitations. For example, most of the previous works focused on learning from one aspect of the data, like only recognizing the activity or only identifying the person. However, activity recognition and person identification are closely related. Sharing knowledge between related tasks leads to learning generalized representation, helping to reduce the risk of overfitting, and therefore, combining them into one multitask model is reasonable and can be beneficial for both tasks. Second, many person identification methods are based on iris, face, or fingerprint. These methods require specific cooperation from the users. It would be better if the person identification model can take different inputs to complete the identification task. Some other works identify person based on limited number of activities. For example, gait recognition-based person identification. It assumes walking is the only activity to be performed during the identification. But in real world, this assumption may not hold. In this work, we proposed a Siamese networks-based multitask model. The model will map the data into two representation spaces, one space for the activity, the other space for the person. In the activity representation space, the data will be grouped together if they are the same type of activity, or stay away from each other if they are different activity types. Similarly, in the person representation space, if the data pairs are from the same person, they will stay closely. But if the data pairs are from different person, they will stay away from each other. We visualize the representation vectors in the two representation spaces. The first row is the activity representation space, and the second row is the person representation space. As we can see that each type is grouped into its own cluster in each representation space. We compare the results from our model with the results from other published works. As we can see, the proposed multitask method achieved competitive performance on both tasks compared with the supervised single-task approaches in most situations. In the second experiment, we expanded the proposed multitask model to include additional attribute representation learning. Here we choose the gender of the person as another representation learning task. The experiment results show that 3 types of different representations are learned successfully. So we know this model can be easily expanded to other related representation learning tasks. In the third experiment, we consider that in real-world application, it will be impossible for the model to have complete and perfect information about the similarities between all data items and for all attributes of interest. Therefore, we divided the data set into 2 parts of equal size. One part of the data only provides the similarity information of the activity types, while the other part of the data only provides the similarity information of the person identities. As shown in the result table, with only partial similarity information, the performance of the multitask method is relatively close to the performance of the multitask method using the complete similarity information. So it indicates that with partial similarity information, the model is capable of effectively utilizing cross-task information to achieve performance that is competitive with other models. To further understand the effect of the multitask learning framework, we conducted a series of appellation experiments. Each single task model is trained to learn only one task, and we can see from the results that expanding the model from single task learning to multitask learning does not cause performance loss in most cases. On the contrary, the performance of multitask model is most of the time better than the single task models. Okay, this is a short presentation about the paper. Thank you.